Emergency response often requires immediate action. To work safely, you must understand the risks and hazards you might face. Handling oxidizers can be one such hazard. It is important to know what oxidizers are so you can understand how to respond when they are present. Chemtrek can provide information about any chemical or oxidizer encountered during an emergency response. Chemtrek's telephone number is 1-800-424-9300, and their staff is available to answer any questions. Safety first, in the way we work, the way we train, and in our emergency response. Over the next few minutes, this program will discuss 4 important areas of a class of chemicals known as oxidizers. 1. What is an oxidizer? 2. How does it behave under different conditions? 3. How can you manage specific hazards posed by different oxidizers? 4. How to safely handle and control oxidizers. Safety information will be highlighted throughout the program. So what is an oxidizer? One definition: an oxidizer is a substance containing oxygen, which gives up that oxygen readily to stimulate the combustion of organic material. Oxidizers allow oxygen to combine chemically with other materials in a way that increases the chance of a fire or explosion. Oxidizers may be found in all 3 physical forms: gases, from chlorine to nitric oxide and oxygen, inert gases like argon, helium, and nitrogen, and a whole range of flammable gases like ammonia, hydrogen, and propane. Liquids like bromine and nitric acid, or solids, oxidizing liquids and solids, can be severe fire and explosion hazards. The typical oxidizing agent is a substance that does not burn, but will support combustion, even in materials that ordinarily would not burn. Some oxidizers don't release oxygen, but do release another gas or chemical that will support or intensify combustion in a similar manner. So the word oxidizer means any substance that gives up a gas or a chemical which is itself not a fuel, but which will enhance combustion. Let's look at an example to consider the hazards. Nitric acid is a strong oxidizer and is extremely corrosive. This container of nitric acid was accidentally broken and released its content onto the ground. There it came in contact with wooden rail ties, causing them to ignite. Early into the incident, technical advisors and product specialists determined that the best way to resolve the incident was to attempt to neutralize the spilled acid. Soda ash is very effective at neutralizing nitric acid. When responding to a chemical spill, always use the proper personal protective equipment, or PPE. Fire requires 4 components: fuel, the presence of an oxidizer, such as oxygen, heat energy, and a chemical reaction among the elements that is present. Our model is called the fire tetrahedron. In order for a fire or combustion to occur, each of the 4 components must touch the other components. Eliminating any of these 4 factors will prevent, suppress, or control the fire. Let's consider an example of this interaction. Oxygen is a familiar oxidizer. In air, the concentration of oxygen is about 21%. However, if we reduce the oxygen content below 19.5%, we will begin to suffocate. So will fires. But if we increase the oxygen content above 22%, what could happen? For example, our chemist has added oxygen to the material in this container. Not only does an enriched oxygen atmosphere bring the fire back to life, it burns much stronger than before. This example spotlights an additional problem in dealing with oxidizers, such as oxygen. Materials that we thought to be non-flammable in air can become highly flammable upon contact with an oxidizer.
All oxidizers pose a potential hazard. By understanding the 4 elements required for fire, you will be better able to prevent and manage incidents. Emergency responders have several options in managing fires or chemical reactions that involve oxidizers. Some firefighting agents may not be effective in controlling large fires involving oxidizers. Depending upon your resources, the best choice may be to let the fire burn and protect exposures. In most instances, water is the only effective agent, unless specifically stated that water should not be used. This lab coat was soaked in an oxidizer and then allowed to dry in open air. After it dries out, the coat spontaneously bursts into flames. Remember that small amounts of moisture or water on some oxidizers can produce fumes, heat, and combustion over a period of time. Carbon dioxide, or CO2, is another common extinguishing agent. In some dry chemical extinguishers, CO2 acts to exclude atmospheric oxygen from supporting the combustion. However, CO2 isn't effective in dealing with oxidizer fires because most oxidizers generate their own supply of oxygen or another oxidizing gas under the carbon dioxide blanket. For the same reason, firefighting foams may also be ineffective in dealing with oxidizer fires. Another common liquid oxidizer is hydrogen peroxide. Hydrogen peroxide carries an ID or UN number of 2015. UN numbers are 4-digit numbers that identify hazardous substances. Hydrogen peroxide is often found in bleaching agents and disinfectants. In high concentrations, hydrogen peroxide is a powerful oxidizer and can be quite dangerous. Hydrogen peroxide is water clear and almost odorless. Skin contact may result in irritation and burns. Commercial grades can release vapors which may cause irritation of the nose and lungs. Since it is practically invisible, proper breathing apparatus and PPE is mandatory when handling hydrogen peroxide. At the scene of an incident, one of your objectives is to prevent this reaction from starting. This is accomplished by isolating the hydrogen peroxide from other organic materials, like wood. Observe what happens to sawdust, an organic material, as concentrated hydrogen peroxide is added. This is what happens when inorganic materials, such as metal filings, are added to concentrated hydrogen peroxide. Look at how the rapid release of oxygen causes the liquid to cloud in the beaker. As the volume of released gas increases, the balloon at the top of the beaker expands. In a closed container such as a drum, this rapid generation of pressure could lead to rupture. This container of temperature-sensitive organic peroxide was allowed to heat up above its SADT, or self-accelerating decomposition temperature. And it decomposed violently. If an incident involving organic peroxides does occur and a reaction has started, isolate and evacuate the area. Water may be applied in a heavy spray from a safe distance using unmanned monitor nozzles to help absorb the heat involved by the thermal decomposition of the organic peroxides. Most gaseous oxidizers are heavier than air. This means the released gas can collect in low-lying areas. Settling of gaseous oxidizers at ground level increases the possibility of the gas coming into contact with organic or inorganic materials and ignition sources. Chlorine is used to purify water, bleach paper, wood pulp, and textiles, and for making a wide variety of other chemicals and products. In its gaseous form, chlorine is greenish-yellow and has a pungent, suffocating odor. In low concentrations, you will smell the gas before you see it. We've prepared a container of chlorine gas. Since chlorine is heavier than air, it flows toward the ignition source. When a piece of wet steel wool is placed into the beaker of chlorine gas, the steel wool corrodes at a very high rate due to the combination of chlorine gas with the moisture to form hydrochloric acid. The visible evidence of this oxidation is the brownish rust-like residue you see on the paper towel. Therefore, if you are faced with a leaking tank of chlorine, don't get water on the area of the leak. The water will create a corrosive solution which may act to increase the size of the leak. Oxygen is classified as a non-flammable gas. Since the color of cylinders may vary, always look for the product label. The product label includes the name of the material, an ID number, the hazard class, and other precautionary information. Non-bulk containers such as this one may be labeled oxidizer. The label may also read oxygen instead of oxidizer. As we mentioned earlier, oxygen is one of the gaseous oxidizers you may encounter in an incident. In this demonstration, we have a lighted cigarette which you can see is burning slowly in air. When we flow concentrated oxygen over the cigarette, it bursts into flames. This illustrates why it is important to keep all ignition sources away from an oxygen-enriched atmosphere. We've shown how many oxidizers can react with organic materials such as wood, cloth, or paper. An organic material, by definition, contains the element carbon. Most organic materials will cause a reaction resulting in the generation and release of gas with many oxidizers.
Follow safety precautions when arriving at the scene of an incident that may involve oxidizers. First, approach the scene cautiously from an upwind and uphill position if possible. Isolate the area and deny others entry. Once you've entered the incident area, identify the oxidizer, if it's possible to safely do so. Then eliminate possible ignition sources and attempt to isolate the oxidizer from other materials. Contain runoff if possible. When handling any of these materials, always use all appropriate PPE. Depending upon the material involved, this may mean wearing a fully encapsulating suit or Level A protection. In cases where an oxidizer is involved in a fire, the minimum protection may consist of structural firefighters' protective clothing and self-contained breathing apparatus. In all cases, verify that the level of protection is adequate for the materials involved. When working in the proximity of oxidizers, always be alert and prepared to respond should an emergency situation arise. If the incident involves fire, let it burn and concentrate on protecting personnel and exposures. Immediately call Chemtrec at 1-800-424-9300 if you need technical assistance. In this program, we discussed only a few of the chemicals in the oxidizer hazard class. There are many other chemicals in this hazard class. Again, oxidizers are one of the 4 components necessary for combustion: fuel, the presence of an oxidizer, heat, and a chemical reaction. The model we used was called the fire tetrahedron. We emphasized the importance of the 4th component, chemical reaction, especially in dealing with oxidizers. When handling an incident involving oxidizers, always obtain technical advice as soon as possible. Call Chemtrec immediately at 1-800-424-9300. They will provide you with initial response information while quickly putting you in contact with product specialists or technical advisors. Oxidizers can pose a hazard. By understanding them and how to manage and respond to incidents, you will be better able to respond effectively if emergencies arise. Respond safely. Be prepared.